All right, kids, welcome to Mr. Reed's fun algebra class. I'm not going to talk like that the whole time. I apologize. I'm just very bored here in my house. So here we go. I don't want to waste too much of your time. I want you to just have to do the math work in just the time slot for this class and then not have to worry about homework or anything. So I'm going to get right to it. First, if you're watching this video and you've not commented here on the announcement for today, you need to go in and do that now. That's a part of attendance for me. So you just leave a comment here, okay? Second, okay, when this class period is over, since I'm making this recording for multiple classes, I can't tell you that. Look back at the announcement. It should specify the time at which this assignment is due. So make sure you set an alarm or whatever you have to do so that when this class is up and it's time for you to start your next class, you just turn in whatever you have for the assignment, okay? So essentially what I'm saying is there shouldn't be any homework here. You should, in the time slot that you have for my class, Algebra 1, you should have time to watch this video and finish the assignment and turn it in. It will be due at the end of class. Last, when I get to the assignment, which is going to be 9.2b, I have 9.2 up right now because I'm going to go over an old example. When we get to 9.2b, I guess we could just do it right now. When we get to 9.2b, numbers 5, 6, 13, and 14 will be crossed off. You do not have to do those. So numbers 5, 6, 13, and 14. But that'll be when we get to the homework 9.2b. To start today's lesson, I'm going to go to what should have been old homework before we went on break, which was worksheet 9.2, which was yellow, I think, the yellow color. Okay, and I'm just going to do number 15 really quick. Just to kind of give us a refresher, today's lesson is 9.2b, and that's what's going to be collected. And 9.2b is obviously based on 9.2. So here's a quick review from 9.2. This is number 15 from the yellow. Okay, and what we have to remember how to do is we have to remember how to substitute. All today is going to be substitution. Substitution, Substitution will be 9.2 and 9.2b. Okay, so to remember how to substitute, right? We look at our system. We're given two equations in number 15, and one of them was always set equal to a variable. So notice how the bottom equation has a y by itself on the left-hand side. We would identify that, and now we'd say, okay, that means anywhere there's a y, I can now substitute 4x minus 8, and this was called substitution. So when I look at the equation above it where there's a y, I'm going to end up taking out that y. If you look at what I have written below here, right, I'm going to take out that y, and I'm going to plug in 4x minus 8. So let me use a different color here. I'll go with like this magenta, all right? So y equals 4x minus 8. And what we're going to do is we're literally going to substitute 4x minus 8 into where the y would have been from the top equation. So down here, I don't want that. I want this. Down here, all I did was rewrite the top equation, negative x plus 4, and then I took out the y and plugged in 4x minus 8. Okay, and then from here, since I'm going to do a bunch of these in the problems, I'm not going to do the rest, but we would distribute first, okay, and then I combine like terms. I eventually came down and solved for x. After I solved for x, I took one of my initial equations, so that's up here. I chose one. It doesn't matter which one you choose, okay, and then in green, I plugged in for x. If x was equal to 1, okay, x is equal to 1, then I plugged in, okay, here's an x right there, okay, so y equals 4, and then instead of x, I substituted a 1, and then I solved, and that's how I found my y. Some of us, our heads might be spinning, like, oh my gosh, I don't remember this. Do not worry. I will go through and do full examples from 9.2b. This is just a quick refresher for some of us, just to remember what we did before. So our final answers are written as x, y ordered pairs. X is 1, y is negative 4. Okay, so that's substitution. Now let's go to what the homework is going to be, which is going to be 9-2b. So if you have your binders, you could do it in your binder. It should be blue, 9-2b, or is this green? Is this blue or green? It's blue. Okay, 9-2b is blue. All right, and this is what your homework is going to be. Again, cross off 5 and 6 as well as 13 and 14. All right, I'm going to go through 2 examples. I'm going to talk about 2 more examples. You can see I have answers there already. And then the rest of the time is going to be for you to finish this assignment. All right, so substitution part B, okay? The difference between 9-2b and 9-2 is going to be what we're given. So in number 1, if you look at our 2 equations in our system, okay, you'll notice that neither of them are solved for a variable, meaning there's no one that says y equals and then, some numbers. Okay, they both are written in this standard form where there's no variable that's solved for. So what we have to do in 9-2b is we choose an equation, one of them, either the top or the bottom, and we're going to reorder it so that it looks like y equals, and then numbers, or x equals, and then some numbers. So we're going to have to do some reordering before we can do our substitution. All right, so let's start there. Okay, step 1, if you read through these top instructions, you may find this pretty helpful too. Okay, 1 says identify which equation has a variable that is a coefficient of 1 or -1. And what that means is that one of these variables, so there's, in our first problem, we have 2 equations. Each of them has 2 variables. One is 3x, one is 7y. They have -6x, and then we have y. Only one of them, in this case, has a coefficient of 1. Can you find the one that has a coefficient of 1? I feel like I'm doing Dora the Explorer here. In case you didn't know, it's going to be this one, right? The coefficient is the number in front of the variable. So of these variables, the 2x's and the 2y's, only this one right here has a coefficient of 1. So I found the equation that has a coefficient of 1. That's step 1. Okay, step 1, identify. 2, isolate that variable. Either get y by itself or get x by itself. So I'm going to take this bottom equation, and what I'm going to do is I'm going to rewrite it so that, once again, I know what I want it to look like. I want it to look like y equals, and then, it's going to be a set of numbers. I'm just going to make some up, like 5x minus 1. That's my goal. That's my goal. That's what I want it to look like at the end. So I'm going to take this bottom equation, all right, I'm going to rewrite it, and I'm going to reorder it so that my y, in this case, the coefficient of 1, that y is by itself. So what that means is that I need to get rid of the -6x. So my next step is going to be, how do I get rid of this -6x? And the answer is to add 6x. -6x plus 6x is 0. Bye-bye. Golden rule of algebra. What I do to one side, I have to do to the other. And I have plus 6x on this other side. Okay, can I add together -10 and positive 6x? No. No, you cannot. I cannot add those together because those are not LT. They are not like terms. So I can't take -10 and 6x and add them together. So I'm just going to end up writing it out. So here's what it looks like. On the left side, I have just a y. This canceled. Equals. On this side, I have a positive 6x and a -10, and I write it like that. I would put the variable first. I don't like that 0. I don't like that 0. There we go. Okay. So now, what we're going to do here is going to be the same as 9.2. So this is really the only new step. The new step for 9.2b is choosing one of our equations, choosing one, the one that has a variable with the coefficient of 1, and reordering it so that I get my equation here in the bottom, y equals 6x minus 10. Once I've done that, now what I'm going to do is exactly what you would have done on 9.2b. I'm going to take, let's go orange. I'm going to take this top equation, the one that I just didn't reorder, so the other one, and I'm going to rewrite it. But when I rewrite that top one, I am going to substitute. I'm going to take out the y from that top equation, and I'm going to plug in 6x minus 10. So it's going to look like this. 3x plus 7, and then instead of y, I'm going to substitute 6x minus 10. Okay, and then finish it off with an equals 20. All right, so the whole reason I did the step in blue was because I had to rewrite an equation where it's y equals. I did that, so now I can substitute that 6x minus 10 into that top equation. And now from here, it's just going to be, and they're all going to kind of come out the same way. You're typically going to distribute first, right? Distribute first. I just write, let's see, we have 3x now. 7 and 6 is 42x. And then 7 times negative 10 is negative 70. Make sure you distribute to both terms. Okay, and now from here it's going to be pretty much always the same, right? We're going to come in, we're going to have some like terms. We're going to bring those together. They're on the same side, so I could just say, all right, 3 and 42 is 45. Drop down everything else. Okay, and then I'm 2 steps solving for x, right? I add 70 both sides. Okay, now I have 45x equals 70 and 20 gives me 90, and my final step is to divide by any number that's in front of my x, which in this case is 45, giving me x equals 2. All that work just to find an x of 2. Okay, so now that's part of my final answer. Remember, I have 2 answers. I have an x and a y. So my x is 2. But what is the y? And how are we going to find the y? Well, substitute again. We do substitution again. This one's usually a little easier. Okay, now that I know that x is 2, that's down here, okay, I'm going to look at both of my original equations. I got all this stuff around them. I'm going to get rid of it. Okay, and we're just looking at the 2 equations. You get to pick which one you want to plug in for x, and it does not matter which you choose. They both have an x. You could choose either one. I'm going to choose the one that doesn't have the negative, that negative 6 there. But really it doesn't matter, so I'm just going to choose the top one. All right, so here's my equation I'm going to choose. I'm going to rewrite it, but instead of x, I'm going to plug in 2. This 2, that x is 2. All right, so here's the substitution. Let's write it. 3, but instead of x, it is now 2. Remember, with substitution, if I'm substituting for x, that means I'm taking the x out. There should not be an x still in the equation. So 3, instead of x, it's a 2 plus, and then 7y equals 20. All right. And now from here, it's just solving again. 3 times 2 is 6. All right, and now it's a 2-step equation again. You'll be doing a lot of these as we had been doing before break. All right, 7y equals 14, and y equals 2. Divide by 7 there. All right, so x is 2, and look at that. Y happens to be also 2. And that's my final answer in blue there, that ordered pair. But I found x. After I found x, I plugged in x and found y. So there's all of it together. There's all the work for number 1. Okay. I'm going to do number 2. It's going to be kind of the same way, except number 2, we're actually going to get to solve for x instead of y, but the process is still exactly the same. The work should all look the same. Pretty much all your work is going to look like this. All right, so let's go ahead and start number 2 for sake of time. All right, so number 2, all right, you look at the equation and you find there's 4 variables, 1, 2, 3, 4, and you find the one that has a coefficient of 1 or negative 1. We have a winner, right? There's my x there has a coefficient of 1, so that's my guy. I'm going to start there. So I'm going to take that equation and I'm going to rewrite it. So x minus 8, y equals 9. It doesn't always have to be the bottom one. It could be the top one. It just so happens my first 2 examples, it's the bottom one that has my variable with just a 1. All right, so now, same as the last one, I'm going to go ahead and solve for x. So I'm going to get rid of this negative 8y. If you look back at the last example, how did we, we solved for y, and how did we solve for y? We got rid of the x, and how did we do that? We added or subtracted. So let's go back to this problem. Okay, I have x minus 8y. How do I get rid of this negative 8y? I'm going to add 8y. Goodbye. What I do to one side, I have to do to the other, but I don't have like terms on the other side, so it ends up being, all right, I drop down this x equals, I have a positive 8y on the right, and I have a positive 9 on the right. So there it is. That's the new step of just reordering one of my equations so that it is either x equals, right? X equals, or, like in the last example, y equals. Okay, that's what we're trying to do with our first step. And then after that, we're just going to substitute. So since I rearranged the bottom one, I'm going to take my top equation. Here it is. And I'm going to rewrite it. Oh, actually, I think I've been using orange. Should I use orange for that second step? Yeah. Okay, so I'm going to rewrite it, except instead of an x here, I'm going to substitute x for 8y plus 9, because x equals 8y plus 9. So anywhere there's an x, I can substitute 8y plus 9. So I'm going to take that top equation. It goes like this, 8. But instead of the x, I'm going to substitute 8y plus 9. I do this, okay, because I want to be able to solve for a variable, meaning I just want the variable to be like y equals, and then just an integer, just a number, okay? And the only way I can do that is if I only have one variable in the equation. If you notice, after I substituted in this problem, look, all I have are y's. That's good. I like that, okay? I want just one variable so that I can use my algebra skills to solve for that one variable, so that I will, at the end, know what y equals. All right, so these steps are the same. Distribute 64y plus 72 plus 2y equals 6. I have a feeling we're going to get a negative answer here. If I have like terms on the same side, right, bring your variables together. Since both these y's are on the same side, you just bring them together. 64 and 2 is 66. 66y, right? Then just drop down everything else. Okay, I'm going to subtract 72 both sides. There's my negative I was looking for. Okay, so then I drop down again. 66y equals, and that's going to be a negative 66. And then last step, as per usual, divide 66 both sides. All right, so once you've found either y or x, it doesn't matter which one you find first, as you could tell. The last one we found x first. This one we found y first, but that does not matter. Find whichever one it works out easiest for first. Okay, so y is negative 1. There's a lot of work coming in here. Let me get the, don't look at this. Don't look. Don't look, we're too far ahead. I'm just moving this answer over here so it's not in our way. Okay, so once we find y, once again, we're going to go back to the beginning. All right, and we're going to take that y, and we're going to plug it into one of the equations. And again, it doesn't matter which one you choose. So if y is negative 1, I still need to find x. Okay, so which one looks easiest to plug back in for y? Let's look. Okay, I can get rid of all this other garbage. If I wanted to solve, I'm going to guess that this bottom guy looks the easiest. The numbers look the smallest. So I'm going to take that equation, I'm going to rewrite it, but I'm going to substitute y as negative 1. All right, so here we go. X minus 8, and now y becomes negative 1. Okay, and then you're just going to go through and solve it just like you did on the last steps, right? We have a negative 8 times a negative 1. So x, that's positive 8, equals 9. We're going to go ahead and minus 8, minus 8. Okay, x equals 1. So I found x. I already knew what y was from the first one, so my final answer is 1 comma negative 1. So there's all the work for number 2. All right. So at this point, I'm just going to go quickly. I already did 3 and 4. You can kind of see them down there already. I already did 3 and 4. I'm just going to point out some important parts, and then the rest of the work is going to be for you to finish, okay? So you're pretty much just going to 12. I'm going to show you 3 and 4. You should be writing down 3 and 4, doing them yourself. But 5, 6, 13, and 14, you do not have to do. Okay. So here's 3 all worked out, okay? Just one important thing to show you for 3 is going to be this step right here. So I'm going to zoom in. I'm actually going to erase that step. I'm just going to redo it quickly. Okay. And here's what's different. This was the first one where I found a coefficient. If you look at my blue box here, the coefficient was negative 1, okay? And the only difference here is, okay, I'm going to solve still for y, so I added 4x both sides. That cancels, so I'm left with a negative y equals a positive 4x and a negative 17, okay? In previous problems, you would have been done, but obviously for this problem, we still have this negative out in front of the y. So to get rid of that, most of us should know that I divide, actually I use red, I think I use red. I divide by negative 1. And what I do to one side, I have to do to the other. Make sure if you're dividing on both sides, you divide from everything on the right side, okay? And then we would get our final, which is going to be, I'll put it in blue again, y equals, that's going to be now be a negative 4x, and that's now going to be a positive 17, okay? And you could see now when I plugged it back in, right, you can look here and see, right here, I mean, okay, it was negative 4 plus 17, and that's where I plugged it in and finished off the equation. Solve for x, plug back in for x, and solve for y. And there's your answer for 3. And 4, nothing particularly special about 4. It just so happened if you look at the top one in 4, there's an x and a y that both have a coefficient of 1. You just get to choose one. I think I chose y. I chose to solve for y. You could have chosen to solve for x. It wouldn't have mattered. Either one. I chose to get y equals negative x plus 1. You could have chosen to get x. And I just chose y. And that's pretty much it. So 1, 2, 3, and 4, here they are, work answers. That's what your work should generally look like. You don't have to color code like I do, but keep it generally kind of neat. Give yourself space. And yeah, just go through it from there. Again, you don't have to do 5 and 6. No, and then just stop after 12. So really, you just have 6 problems to do with the rest of the time we have, okay? When you're done, when the timer goes off or whatever, when the class is done, you need to turn in what you have, okay? So it's only 6 problems. This should be done for all of us, okay? 6 problems. Here they are, 7, 8, 9, 10, 11, 12, okay? When you're done, take a picture of the work of the blue sheet completed, and upload it to the assignment. You have to go under assignments, and then it'll give you a choice of to upload files, and you just have to take pictures and upload the pictures. If you choose, you could also do this on PDF from the Canvas page under modules. So if you wanted to pull up a PDF version and do it on your iPad, that's fine. Either way works. Just turn in either the PDF version or the pictures you've taken of the blue. And that'll be our first day. If you have any questions, there's going to be a discussion page open under discussions in Canvas, and you can drop any questions in there. If you have a question on a specific problem or a specific step, I'll try and respond definitely before the class is over. I'm at my computer. If something's not working right or you don't think anything's working, you can email me. My email is read.michael@marist.net. Hopefully you know how to spell my name at this point. But, read.michael@marist.net. But it should work out pretty well. We've turned in assignments before. It should work fine. Okay, well, good luck, and